Welcome, everybody, to your Algebra 2 final exam review. Please make a note of this right here. Everyone must complete the review for a grade, even if you are exempt from the exam. So, no, you cannot get out of the review. I am so sorry. So this Edpuzzle is actually going to be skippable. I'm enabling skipping, so you don't have to watch every single question. In fact, I recommend you first do the ones that you know how to do, and then come back for help on the others. And I'm going to put one of those little question markers every 5 questions so that if you want to skip, it's a little easier to skip to the question you want. So I'm going to go through these a little quickly. So you may need to pause here and there, but hopefully this will be helpful. Number 1, the half-life of iodine-131 is 8 days. How long will it take for a sample with a mass of 200 grams to decay to 100 grams? So you are using the decay formula. So you have your ending amount, your initial amount. Here's your half for half-life. So it makes it decay by half every time. You have the amount of time that has passed, and you have the length of the half-life. So go ahead and plug in what you know. We know we start with 200 grams. We're trying to get to 100 grams. We don't know how long it's going to take. That's what we're trying to find out. So leave T. And then the length of the half-life is 8 days. And then you're going to do reverse PEMDAS. So first, you want to add or subtract if you can, which we can't. There's nothing here that's added or subtracted. Then we want to multiply or divide, so I can divide by 200. So boom. So I get 1/2 equals 1/2 to the power of t over 8. Then I'm at my exponent step, so I want to convert this to logarithm form. That will help me get this t out of the exponent. So I have log base 0.5 of 0.5 equals t over 8. Multiply both sides by 8. And put that in your calculator. And so you get t equals 8 days. And here's what it looks like in the calculator. Just like that. So in fact, you'll notice that there's kind of a shortcut to this question. 8 days is the half-life, and if you check that out, there's half of it left. We started with 200, now we have 100. That's half of it, so that's exactly one half-life, which is 8 days. So you could also have done it that way. In fact, some of you did the test question in the Unit 9 test. You did it like that, kind of thought your way through it, which was pretty cool. And then how long would it take to decay to 50 grams? So same thing. I'm trying to get to 50 grams. I started with 200. Now, if you look at so half of 200 is 100. That was 8 days. Half of 100 is 50. That's 8 more days. So this should come out to 16 days. So you could kind of think of it that way, or you could go ahead and solve using reverse PEMDAS. Either way, your question on the test will be kind of like this. It's going to be a nice even amount of half-lives so that you could do it, you could kind of reason through it that way if you wanted. So guys, remember that this here is not an exponent. This is a subscript. In fact, I'm going to make that a little bit clearer the way I wrote that, because I keep seeing that a lot when you guys write logarithms. This is a subscript. I'm going to make it real obvious. That's a subscript. And then this here is just normal size. It's not a subscript. It's not an exponent. It's just like if there were a line right here that we were writing on, it'd be right on the line. So please don't make that an exponent. The exponent is t over 8. Okay, so, and then multiply both sides by 8 again. And I put that right here in my calculator, and I get t equals 16 days. All right, number 2. What is excluded from the domain and range of each of the following? If you don't remember your transformations very well, I would suggest graphing these. So these are all rational functions. So graph these. They're all rational functions. So when you're looking for exclusions, you're looking for asymptotes. So kind of like you have your graph kind of like that. So your vertical asymptote excludes the domain because it goes through the x-axis, and your horizontal asymptote excludes the range because it goes through the y-axis. So let's check out a few of those. Okay, now if you still have your Chromebook and you want to use Desmos, that's better because I just feel like it's easier to see, but a lot of you don't, you didn't pay your insurance, so you're going to have to use an Inspire. So I would recommend going to Menu, and then View, and then Grid, and put a line grid on there for yourself so you can see a lot easier where the asymptotes are. So you can see the horizontal one is right about here, which is going to be 1, 2, 3, 4, 5, 6, 7, -7. Okay, so -7 is excluded from your range, so you can just kind of say y is not equal to -7. And then from your domain, you're going to look for the vertical asymptote, which is right about here at 1. And if you need to zoom out, you can. So you can see a little easier, but it's right about 1. So x is not equal to 1. And then do kind of similarly for each of these. So here's B. Now I've had to zoom out on B. So I've got 2, and notice these are numbered by 2's now. 2, 4, 6. So -6 is excluded from the domain. So x is not equal to -6. And then from my range, so it looks like, oh, well, let's try tracing. Kind of hard to tell on that one from the graph. And sometimes you want to skip to another x value. So it looks like it's kind of approaching 5. So that horizontal asymptote there is going to be at 5. So y is not equal to 5. So I've graphed C. Now I want to put my window back to normal. So I'm going to go Menu, Zoom Standard, number 5. And yeah, I probably shouldn't have done that actually. So zoom out again. Zoom there. Okay. So I can see 1, 2, 3. Vertical asymptote is about at 3. So x does not equal 3. And for my horizontal asymptote, I can see it right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So right about -11. By the way, if your function is written like these, here, right here, there's your x, your domain exclusion, and there's your range exclusion. So flip that sign, and that one stays the same. So that's just like your left, right, and your up, down. When it's written like this, you got to either remember the rules or you got to graph it. So I think most of you are going to want to graph it. And so here's D. Now I've zoomed out on D also. So it looks like I've got a horizontal asymptote. Let's see. Come on. It's not letting me grab it. Well, it should let you grab this and move it around. But it's not letting me. Oh well. So let's zoom out again. Okay, there we go. So it's numbering by 5. So 5, it's actually going to be at 16 there. So x is not equal to 16. The numbers on the test are going to be easier to see. These are just kind of tough a little bit. So 2, 4, 6, 8. So your horizontal asymptote is about at 8. So y is not going to be equal to 8. Number 3, an antibiotic is introduced into a colony of 15,000 bacteria during a lab experiment. The function below can be used to model the number of bacteria in the colony after m minutes. So the first thing, well, how much time is needed for the population to drop to 9,000? So we're going to plug, and we already got 15,000 in there. So we're going to plug that in just a minute. First thing though, I want you to be aware of this n of m. So last year this confused so many people. This is just like saying f of x, okay? It's not n times m. Don't worry about what n is. This is just like saying f of x, which is, again, just like saying y. So this is your y right here, and m is your x. So if you want to rewrite that this way, you can. Okay, so feel free to rewrite it that way. That's all it means. Now we want to know how much time it's going to take for the population to drop to 9,000. So 9,000 is my number of bacteria. M is minutes. So I'm looking for M or X. And 9,000 is going to go here for Y or for N. So 9,000 equals 15,000 times all this. I'm gonna go ahead and use M, but if you want to use X, it's not hurting anything. Okay, and now we got to solve this just like you solved number 1 with reverse PEMDAS. So there's nothing here I could add or subtract to get rid of, but there is something that's being multiplied right here, which means I can divide it away. So, and it's 3/5, which is 0.6. Okay, so there. And then when my variable is up here in the exponent, I need to turn this into a logarithm. So I have log base 0.637 of 0.6 equals m over 5. So then put that in your calculator. Let's see what we get. 1.13269 equals m over 5. And then just multiply by 5 to get rid of that denominator. Oop, oop, I'm in the parentheses now. So m equals 5.66344 minutes. Depending on the answer choices, you may need to round that off a little bit. But it'll either tell you or it'll be obvious what to round to. Okay, number 4, what is the domain of the absolute value function below? So remember, domain is your x values. So I'm looking at left to right. Now, when your line goes to the very end of the grid like that, remember that there's technically an arrow on both ends. So how far left can my graph go? There's an arrow there, so it can go left forever. It can also go right forever. So that means I can have any value that I want for x. So my domain is going to be all real numbers. So you could see x is an element of all real numbers. You could just see all real numbers. You could see negative infinity to positive infinity. So just remember those different ways to write it. Number 5, what is the solution of that equation? So it's a square root equation, so it's a reverse PEMDAS problem. So is there anything that I could add or subtract? Yes. Now this, when there's like a negative number in front of your grouping symbol or your parentheses, that tends to confuse people. So you got to think about, I need to cancel a negative 6. It's a negative 6 that's added to the rest of the equation. It is not multiplied or divided. So it's definitely this step right here. How can I cancel a negative 6? It's like, how can I cancel a debt of $6? Well, I need positive $6, right? So I'm going to add 6 to cancel that. Negative 6 plus 6 comes out to 0. So that cancels. So then I have the square root of 5x plus 4 equals 10. So that's done. There's nothing I can multiply or divide that's not in that square root, so I can't do this right now. And now I have my exponent step. So remember, the square root is an exponent. It's an exponent of 1/2. And some of you liked writing it. When we did this unit, some of you preferred to write it this way. So it's just really up to you whether you want to leave it like this or you want to write it like that. Either way, you need an exponent of 2 to cancel that out. So you're going to square both sides. Let me do this. Okay, so either way, square root cancels the square. 1/2 exponent cancels the square. It's the same thing. And then you end up with 5x plus 4 equals 100. Either way. Finished my exponent step. Now I'm in the parentheses or the grouping symbol. So I start back at the bottom. Can I add or subtract anything? Well, I sure can. I can subtract 4. There we go. So I have 5x equals 96. And then finally divide by 5. And that gives me 19.2. Now you do want to go back and check. So plug it back in and make sure it's not extraneous. So I'm going to type -6 plus the square root of 5 times 19.2 plus 4. And make sure you get 4, which you do. So it is an actual solution. It's not extraneous. Yay. Number 6, Shauna can pour a large concrete driveway in 2 hours. Dan can pour the same driveway in 8 hours. Find out how long it would take if they worked together. So this is this kind of problem where I have Shauna plus Dan. So Shauna's work plus Dan's work, that looks funny, equals the work they do together or total. I can't spell today. How sad is that? There. So Shauna can do one driveway in 2 hours. Dan can do the same driveway in 8 hours. And I want to know what they can do together. So hopefully you remember doing this February or so, I believe it was. So when I add fractions, I need a common denominator, or I could turn them into decimals too. That would work. I'm going to go ahead and get a common denominator. So my common denominator is actually 8 here. So 4, multiply these by 4, that I can leave alone. So 1/2 is the same as 4/8 plus 1/8 equals 1 over x. 4/8 plus 1/8 is 5/8 equals 1 over x. And I can cross multiply. So 5x equals 8. Divide by 5. And get x equals 1.6 hours. Number 7, what exponential statement would be equivalent to this log? And a hint, that just means convert it to exponential form, that's all. So remember that you have log with your base, and then you have whatever you have in here, your argument. And that equals your exponent. So then when you convert it, you have the base to whatever your exponent was equals your argument. So you want it to look like this. So I'm going to take my base, which is 2, and then find my exponent, which is going to be on the other side, so 3, and then equals my argument, x minus 5. Now, it doesn't say solve, so you don't have to figure out the value of x. That's it. You're done. Number 8, simplify. 5 over x minus 1 over x plus 2. Fractions again, so we need a common denominator. So remember, when you have fractions with x or with x's in them, the easiest way to find the common denominator is to multiply each fraction by whatever the other denominator is. So I'm just going to actually rewrite it first so I have some space. So I'm going to multiply the first fraction by x plus 2 over x plus 2. And I'm going to multiply my second fraction by x over x. And then I'm going to combine. So I'm going to go ahead and multiply actually before I combine. So 5 times x is 5x. 2 times 5 is 10. And then minus. And then 1 times x is just x. And then x times x is x squared. 2 times x is 2x. And then that denominator stays the same because you always keep the same denominator once they're common. So then I just need to combine like terms on top, which I have 5x's and I'm taking away an x, so that leaves me with 4x plus 10 over x squared plus 2x. And these terms do not all have a factor in common, so that means I'm finished. Number 9, solve for x, round to the nearest hundredth if necessary. So I'm going to figure out the value of x using reverse PEMDAS. So I want to start by adding or subtracting. And in this case, I can subtract 4 from both sides. And here's where a lot of kids will make a mistake. They'll try to do the reciprocal exponent next and forget this guy right here. Don't make him sad by forgetting him, please. The exponent does not apply to the 5. The exponent applies only to the x. So you got to cancel the 5 first. So you got to divide by 5 next. Then you can do your reciprocal exponent. So I'm actually going to rewrite it so I have some room. So I never leave myself room on these. So the reciprocal of 3 over 2 is 2/3. Make sure you do that on both sides. 2/3 and 3 over 2 cancel each other out because they're reciprocals, and you get x equals 2.08. And then it goes 0.008, but it did say round to the nearest hundredth, so I don't need those. X equals 2.08. Number 10, give the equation for all vertical asymptotes of this graph. Now, if it's given to you factored like this, all you have to do is flip these two signs and you got it. That's it. It would be x equals -5 and x equals 1, but let's just graph it. Let's check, because I know a lot of you are going to want to graph it. So here's my graph, and you can tell there's a vertical asymptote here at -5, so 1, 2, 3, 4, 5. Oops. And at +1. So -5, +1, and they are x equals lines because they go straight through the x-axis. So either way you do it, that's all I got to do. Both of those.